For years, AI coding meant autocomplete. You typed a function name, and the model guessed the next line. Sometimes it guessed a whole block. Sometimes it saved you a few minutes. But the workflow still belonged to the human. You understood the task. You opened the files. You ran the tests. You read the stack trace. You decided what to change next. Coding agents change that interface. A coding agent is not trying to predict the next line of code. It is trying to complete a task. It can read the repository, edit files, run commands, inspect failures, and come back with a proposed change. That is why coding agents are suddenly becoming mainstream. Not because the model alone became magical, the model got better, but the bigger change is that the infrastructure around the model finally caught up. The agent now has context, tools, feedback, permissions, tests, Git, and review gates. It is no longer just writing code. It is operating inside the software workflow. The easiest way to see the shift is to ask, what is the unit of work? With autocomplete, the unit of work is a token, a line, maybe a function. The model suggests text, and the developer decides whether to accept it. With a coding agent, the unit of work is a change. The request might be, fix this failing test, add this API endpoint, migrate this component, refactor this module, update the docs after changing the interface. That task cannot be solved by prediction alone. The agent needs to inspect the project. It needs to understand local conventions. It needs to edit more than one file. It needs to run checks. And when the first attempt fails, it needs to use the error as information. That is the core difference. Autocomplete is a suggestion engine. A coding agent is a feedback loop. A useful coding agent has 4 layers around the model. The first layer is context. The agent needs the task description, but it also needs repository structure, relevant files, dependency information, documentation, previous errors, and sometimes issue or pull request history. A model that cannot see the right code cannot make the right change. The second layer is tools. Reading files, searching the repo, editing code, running shell commands, launching tests, calling package managers, querying docs. These are not decorations. They are the difference between a chatbot that talks about code and an agent that works on code. The third layer is feedback. Software gives unusually clear feedback. Syntax errors, type errors, unit tests, integration tests, linters, build logs, stack traces, runtime exceptions. The agent can act, observe the result, and revise. The fourth layer is control. Branches, sandboxes, permissions, diffs, CI, and human review keep the loop bounded. They make it possible to let the agent do real work without letting it silently change production. A coding agent is not just a smart model. It is a model embedded in this stack. This is why software is one of the first domains where agents are becoming genuinely useful. Coding is not easy, but it is instrumented. A software project is full of machine-readable structure. Files have paths. Modules import other modules. Tests produce pass or fail signals. Type checkers explain mismatches. Compilers refuse invalid syntax. Git records exactly what changed. CI systems rerun the same checks in a clean environment. Most knowledge work domains do not look like that. If an agent manages your inbox, the hard part is not just writing an email. It has to understand preferences, relationships, timing, privacy, and consequences. If it books travel, a mistake can spend money or create a real-world scheduling problem. The feedback is delayed, ambiguous, and often social. Software has ambiguity too, but it also has a lot of executable feedback. That is the important sentence. Coding is hard, but it is instrumented. And instrumentation is what lets an agent close the loop. A typical coding agent loop looks like this. First, the task comes in. Maybe from a human prompt, maybe from a GitHub issue, maybe from a failing CI job. Then the agent inspects the repo. It searches for relevant files, reads interfaces, checks, tests, and tries to understand the shape of the change. Then it plans. Sometimes the plan is explicit, sometimes it is internal. But the agent needs a working hypothesis about what to edit. Then it acts. It modifies files. It may add tests, update imports, change configuration, or adjust documentation. Then it runs checks. Tests, builds, type checks, formatters, or a small manual reproduction. Then comes the most important part: observation. The command output becomes new context. A stack trace is not a failure in the human sense, it is a signal. The agent can read it, patch the mistake, and run the loop again. Eventually, the useful artifact is not a chat response, it is a diff. That diff can be reviewed by a human. It can be checked by CI. It can be reverted if needed. The output of a mature coding agent is not code text. It is a proposed, tested change set. So why did this become practical now? Several things matured at the same time. Models became much better at code, multi-step instruction following, and reading their own error messages. Context windows grew large enough to hold a useful slice of the repository, not just a tiny prompt. Tool calling became more reliable, so models could request actions through structured interfaces, instead of pretending to be shell scripts in a chat box. Developer environments became easier to expose to agents. File system tools, terminals, repo search, browser access, package managers, test runners, and API documentation. Cloud and local sandboxes made it safer to run commands without giving the model unlimited access to the real machine. And existing software workflows already had the right shape: branches, pull requests, CI checks, code review, issue trackers, and rollback. No single breakthrough created mainstream coding agents. It was convergence. The cost of the loop, think, edit, run, observe, revise, finally got low enough to repeat. None of this means coding agents are reliable, autonomous engineers. The failure modes are real. If the task is vague, the agent may produce a sprawling diff that technically changes things but does not solve the real problem. If tests are weak, the agent can pass the checks while breaking the intent. If the repo has hidden conventions, the agent may write code that looks plausible but does not fit the architecture. If it generates its own tests, those tests may simply confirm its misunderstanding. Long tasks can drift. Large repos can pollute the context. Dependency changes can create side effects. Security-sensitive edits require judgment. And a stack trace can tell you what crashed, but not whether the product behavior is right. That is the new bottleneck. The problem is shifting from "can the model write code" to "can the system verify that this change is correct?" As coding agents improve, the human role does not disappear. It moves up the stack. Less time typing boilerplate, more time specifying the goal. Less time manually chasing syntax errors. More time deciding what behavior should be tested. Less time writing repetitive glue code. More time reviewing architecture, security, performance, and maintainability. The better the agent gets, the more valuable precise specs, good tests, and human judgment become. A weak workflow says, "Agent, go build this," and hopes for the best. A strong workflow says, "Here is the task. Here are the constraints. Here is the sandbox. Here are the tests. Here is the review gate. And here is what you are not allowed to touch." That is how coding agents become useful in real teams. Not as unsupervised workers pushing directly to production, but as controlled automation inside a software delivery system. AI coding agents are going mainstream because the interface changed. The model is no longer waiting inside the editor, offering the next line. It is inside the development loop, reading, editing, running, observing, and packaging its work as a diff. That works especially well in software because software has feedback. Tests, builds, logs, stack traces, version control, and review systems give the agent a way to correct itself and give humans a way to supervise it. The future of coding agents is not a model blindly committing to main. The mature version is controlled autonomy. Agents working in branches, producing proposed changes, running checks, and handing the result to humans and CI systems for review. The agent is not replacing the software workflow. The agent is becoming another worker inside it.